Hello everyone. Today we are going to discuss the sixth problem of AtCoder beginner contest 331, which is palindrome query. So we are given a string s of length n, and there are q queries, and there are two types of queries. In the first query, we can change the x character of s to the lowercase English letter c, and for the second query, we have to find if the substring found from the index l to r is a palindrome or not. If it is yes, if it is palindrome, then print yes. Otherwise, it is a if otherwise print no. Now this problem is quite difficult, and we have to know string hashing to solve the problem, right? So uh, so let's forget about the problem, like forget about the queries. Now how we can say that if some substring from like we are given a string is, and we have to find if the substring from is I to j is a palindrome or not. So for that, let's say we have some hash map for the string. So we'll check the hash map for s of I to j. Hash of s of I to j is equals to the hash of reverse of s j to I or not, right? Okay. So so what, let's say our string is like a b c b a. Now not let's consider this as a b c d b a b a c, right? So the reverse of this will be c a b d c b a, right? So this is the reverse. So this, let's consider this as s, and let's consider this as rs. So if we want to check that the part this part is this palindrome or not, we'll check if this part hash of this part is similar in hash of this part or not. So the hash of these two will not be equal, so the answer will be no. So let's consider some string which is actually a palindrome. So let's consider some c a b a d c a b a d. Now rs will be nothing but d e b a c, right? Now if we want to take these three characters, the hash of these three in s and these three in s rs will be same, so our answer will be yes. So I hope you got it. Now for finding hash of any string, so you can search about Rabin curve algorithm. Rabin curve. Okay, I will provide the link of the gfg article in the description box also. So for finding that, let's go into the article first, right? So here I will provide the link of the this portion in the description box. So this problem is palindrome substring queries. This is quite similar to our problem. So they are using Rabin curve algorithm here. Okay. So what is Rabin curve algorithm? So for Rabin curve, we will consider finding prefixes. So prefix I is str0 plus str1 into 101. This is some base. You can consider this as some constant. I am using 26 in my problem. They are using 101. Preferably we use some kind of primes. So they're using 101, I think, because of uh, I don't know, I'm not sure. Generally we use 26 here. So str0 plus str1 into 101 plus str2 into 101 square. So they are taking stri into 101 to the power I for prefixes. Now here hash of l comma r will be prefix of r plus 1 minus prefix of l. But here you can check that like there will be, for if you are taking hash of l to r, hash of l to r, and we will be having prefix of l sorry, prefix of r minus prefix of l minus 1, right? Prefix of r minus prefix of l minus 1. Now prefix of r will be like something like a to character, let's say s of r base to the power r, and similarly there will be s of l minus 1 base to the power l minus 1. So here you can say that we can divide everything by b to the power l minus 1 or base to the power l minus 1. So let's take it as common. So it will be b to the power l minus 1. Now is r b to the power r minus l plus 1, like that. And at the end it will be s of l minus 1 b to the power 0, right? So that's what they are doing. They are taking common as there you can find it somewhere. Yeah, they are doing 101 to the power n minus r minus 1. That's what they are doing, right? 101 to the power l, right? So that is the first part of the problem. I am not going into the more detailed explanation for this. You can read in this part, or you can find some YouTube videos to go deeper into this. So what we will do, we will be maintaining some prefix sum for the string in the string and the reverse of the string. So both s and rs will be maintaining some prefix sum array, and for every query of type 2 we'll be checking if prefix sum for l to r and prefix sum for rs for r to l is same or not. If it is same, the answer will be yes, else the answer will be no. So this problem is quite straightforward. If the update is not there, if the type 1 operation is not there, but we are updating the value, we are updating the position x to c, that's why we can't really use some normal 1D array. We have to use some kind of segment tree or binary index tree here. So here for this problem I am using binary index tree. So let's jump into the code. So here I am taking two binary index tree, one for the prefix and another one for the suffix. So one for the string s and another for the string rs, the reverse of s, right? So pre will denote the prefix sum for s, and sub will denote the prefix sum for rs, right? So this part I have already explained here. Why we are doing si minus a into pw of power of I. Power of I will be nothing but base to the power I. Here my base will be 26. So we are calculating the inverse of power. So here you can check that we are doing by 101 to the power l. In modular arithmetic we can't divide, so we have to take modular inverse of 101 to the power l. So some like modular inverse of p to the power m is nothing but b to the power m to the power m minus 2, you can say. So you can read about this. I am not going into this part, right? So we are just building power of pi and inverse of power of pi, right? And we are updating the value of ith index to si minus a into power of I for prefix. Similarly for suffix, we are updating the index I plus 1 to s of n minus I minus 1 minus a. Now when there is a type 2 operation, we are taking the query for l to r for prefix, and we are similarly taking n minus r plus 1 comma n minus l plus 1 for suffix. This will be l to r and this will be r to l. If lr equals to rl, we are printing yes, otherwise we are printing no. So why we are taking n minus r plus 1 and n minus l plus 1? You can just observe that what is the relation between this I and this n minus I minus 1. This is nothing but n minus I, right? N minus I, this part and this part. So that's why I am taking n minus r plus 1 and n minus l plus 1. I hope you got it. And another thing you have to keep in mind is that for binary index tree we have to use one based indexing, not zero based indexing. You can use zero based indexing for segment trees, but for binary index trees you have to use one based indexing. So that's the type 2 operation. This part is quite easy. Now for update operation, so every node, let me clear all this, delete, and so for binary index tree, so for bit of some index will be like is of I into base to the power I, base to the power I. So when we are updating some index I to some character C, we have to delete this, right? So when we are when you take the update operation in a binary index tree, you can check that it is doing binary tree of I plus equals to value, binary tree of I plus equals to value, right? Here also you can check that for update operation we are doing binary tree of index equals to binary tree of index plus value. So that's why we have already si b to the power I here. So we have to now the next value will be c into b to the power I. So we have to delete si b to the power I from here. So this operation, this thing will be added in the update operation, right? The value will be cb to the power I minus si b to the power I. So that's what I am doing here. For the first operation, like type 1 operation, for prefix card will be s of x minus 1 minus a into power of x minus 1. Suffix of card will be same, s of x minus 1 minus a and power of n minus x. So for the suffix operation, you can directly check the relation between these two, right? This index and this index and this index. Okay, so we have already got prefix of card. So what is already present in that particular index? So we have to delete, take the minus of this thing, that which is already present in binary index tree of I. So we are updating x comma c minus a to the power of this part cb to the power I minus prefix of card will be nothing but sib to the power I. And after the update operation, we are setting the value of x minus 1th index to c. I hope you got it. The problem is straightforward if you know about binary index trees and string hashing. I will provide the link of the this question, palindromic substring queries, in the description box. You can go through this. I will also provide the link of my code in the description box. If you have any doubt in any part of the video, you can write in the comment section. I will try to reply each and every comment. Please like the video and subscribe to my channel. Thank you.